Today we're going to be focused on reaction types and solubility. So there are three goals we have here. First, identifying the types of chemical reactions based upon a chemical equation, predicting the products of reaction, and predicting products that will fall out of a solution. So here's the main reaction types that we're going to focus on in this course. Note that one reaction may fall under multiple kinds of reaction types. So you have synthesis. So a synthesis reaction is where two or more things come together to make one bigger thing. Decomposition, if things are decomposing, they're breaking apart, they're breaking down. So in a decomposition reaction, you have one thing breaking apart into two or more things. Single replacement. So in a single replacement, you have one thing, A, replacing another thing, B, or it could replace C in some cases. And typically the A is a metal, but it doesn't have to be. And then double replacement, AB plus CD. And notice that if you imagine these as like dance partners, A and B, dance partners C and D, it's like they're switching partners. And then acid-base neutralization. This is a special kind of double replacement reaction that always produces water and salt. And then combustion. Combustion is where anything is burning. Usually it has carbon and hydrogen. In this class, it's always going to have carbon and hydrogen, sometimes oxygen. It's going to be reacting with oxygen, and it's going to yield CO2 and water. Speaking more generally, this fuel could also have sulfur, or it could also have nitrogen. And then if that was the case, it would produce things like sulfur dioxide or nitrous oxide. Precipitation reactions are also a kind of double replacement reaction, but it's a case where a solid product is one of the two products that are result. And then oxidation reduction reaction is a reaction where the oxidation number of some atoms change. Note that oxidation is loss of electrons and reduction is gain of electrons. So this is oftentimes remembered as oil rig. You can also note that if something is being oxidized, it's gaining oxygens, oxidized. If it's being reduced, it's losing oxygens. So sometimes that is also a convenient thing to notice. There's also a solubility rules table here. You should have this memorized. And remember SNAP. Sodium, those are your alkali metals. Nitrates and ammonium are generally soluble. Phosphates are generally not. That will take you halfway there to having this memorized. Okay. So here's some example of how you would go through this process. So you've got sodium hydroxide and hydrochloric acid. So I just said acid, so that's your acid. And then sodium hydroxide, that's a base. So an acid and a base react to give salt, table salt actually, sodium chloride, and water. So that's an acid-base reaction. But also notice that if you look at the things underlined in blue, if those are A and D, now notice they're together, they're BD, and H and OH underlined in green are now water. So it's also a double displacement. Then for B, notice that zinc is replacing hydrogen. Zinc is being replaced by hydrogen. So this is a single replacement reaction, but also in blue, I've noted the oxidation numbers. So zinc is all by itself. It's an element, so its oxidation number is 0. Hydrogen has a oxidation number of +1, chlorine -1, zinc +2, chlorine -1. Hydrogen in its elemental state, 0 again. So notice that the oxidation states of zinc, hydrogen, chlorine all changed. So it's also an oxidation reduction reaction. So for future reference, the zinc is losing electrons, so it's being oxidized, and the hydrogen is gaining an electron, so it's being reduced. Then C3H8, okay, propane, plus oxygen yields CO2 and water. And I've already balanced it for you, but you can notice two things. It is an oxidation reduction reaction because the carbon and the hydrogen are changing their oxidation states, and oxygen is changing its state as well. But it's also a combustion reaction. And then H2O2, hydrogen peroxide, is a oxidation reduction reaction because the oxygen does change its oxidation state, but also it's a decomposition reaction. Okay. So that covers the examples. With these, again, you're just going to compare them against these patterns and see how many different types you can find. Now, with solubility, I might ask you to tell me whether something is soluble or not. So if something includes something that falls under the SNA part of SNAP, like sodium or nitrate or potassium or ammonium, that's almost basically a giveaway that it is soluble. Calcium chloride, though, is a little bit more troublesome. You've got to go back to that solubility table. So let's look at that. We've got the chlorides. So chlorides are generally soluble. We have to look at and see, does it fall under one of these? Is it a silver chloride, lead 2 chloride, or mercury 1 chloride? No, it is not. So calcium chloride would be considered soluble. And then next, I just would like you to take a moment and figure out the answers to these questions. There's, of course, many possible answers. But remember, when you're determining whether something's soluble or insoluble, if you go back to SNAP, that will make your life a little bit easier here. Many correct answers. And then here's an example of full and net ionic equations with states for each of the reactions. So generally, these are going to be double displacement. They're going to be precipitation reactions. So first, you write down just the plain reaction. So this is what you would oftentimes see. Sodium sulfide and barium chloride, they're both aqueous, yields barium sulfide and sodium chloride. So you would have these. And then you would ask, which one's soluble and which one's insoluble? Well, you have to go back to the solubility table, which hopefully you would have memorized. And you would look at barium sulfide. Oh, sulfides. They're generally insoluble, except for things that fall under SNAs, sodium, alkali metals, nitrates, ammonium. Okay. So that means that barium sulfide is going to be your solid, and sodium chloride, of course, it's got sodium in it, it's going to be soluble. Now, to write down the full ionic equation, you would keep things together if they're a solid. If they're aqueous, you break them apart into their ions. So Na2S produces 2 sodium ions and 1 sulfide ion. And they keep their little AQ labels. Barium chloride produces 1 barium 2 plus ion and 2 chloride ions. Barium sulfide is a solid. It doesn't break apart. It stays as is, but sodium chloride does break apart. And notice it's got 2 here, so it's going to keep the 2 there and there. All right. The net ionic equation, you're just dropping out the things that repeat themselves on the reactants of the product side. So barium plus sulfide yields barium sulfide. This net ionic equation tells you really what's happening in the reaction. So you can just continue on and do the other three. Again, you're just looking to see, write down what happened, what's the basic reaction, then the full ionic equation. So break apart everything that's not solid, everything that has an AQ by it into its polyatomic ions or regular ions, and then net ionic equation, drop out the things on the product reactant side that repeat themselves. And then you can repeat that down here.